So, you can use this on the quiz and the test. I'll let you use them both times, so just because that's always the question. So yes, you can use it on the quiz, yes, you can use it on the test. I printed out extras in case you lose yours, but I did not print like a class set of extras. I printed out like 7 extras, okay? So don't everybody lose theirs. I have enough for like a few people. I can put it on Canvas. I'll do that. Yeah. Okay, so let's go ahead and do a couple class examples just to make sure that we are comfortable with it, and then we have the around the room activity that we're doing today. So, what example number did we leave off of in the video? 6? We did 6? Okay, so we are on example 7. Do you guys like the ring I made for myself? It's from Dr. Davis. This is the rainbow, and this was the pot of gold at the end of the rainbow. It's adorable. All right. Example 7. Okay, we're going to do 36 to the negative 3x equals 216 to the 2x. And now everybody has a chart that they can look at easily. And so we're going to figure out 36 and 216 are in which column? Yeah, the 6s. They're in the 6s column, so we're going to rewrite both of those bases as a 6. So 36 is 6 to the what? 2. So I'm going to write this as 6 to the 2, and then I'm going to keep the negative 3x on the outside. And then the 216 I'm going to rewrite as what? 6 to the 3rd to the 2x on the outside. Okay? And then if you have an exponent raised to an exponent, what do? Multiply. Whew. It's okay, your brain tooted a little bit, but we got you. It's just a little brain, you know? All right, so we got 6 to the negative 6x equals 6 to the positive 6x, and at this point we can take those bases, we can just get rid of them. And so we can say negative 6x equals positive 6x. And then whenever we have a variable on both sides of the equation, what's our goal? Yeah, or just get the variable to one side. We don't want to have the variable on both sides. Okay, so would you rather take the positive 6x and move it to the left side, or take the negative 6x and move it to the right side? Okay, so I'm going to add positive 6x, I'm going to add positive 6x. Okay? And so this side is going to 0 out, and that side's going to be 12. So we've got 0 equals 12x. And then how am I going to keep the x alone? Divided by 12. And 0 divided by 12 is 0. So x equals 0. Okay. And if you want to check your answer, you can. So one of the ways that I like to check my answer on my calculator is I like to take the value for x and just store it in the calculator. Let me zoom out. So we found that x was 0, so I'm just going to type the number that I got first, 0, and then I'm going to hit STO, which is right above the on button. So STO, I'm going to store that as x. You can use it up here, or you can do alpha STO. Yeah. Oh, I just had 0. So 0 STO, I'm going to store it as, I forgot I was in different mode. Okay, hold on, let me go back. 0 stored as x, so it looks like that. 0 stored as x. Everyone see that? Okay, and so now I'm going to type in 36 to the negative 3x and 216 to the 2x, and I'm just going to make sure that the left side and the right side of the equation both have the same output. So the left side of the equation outputs 1, the right side of the equation outputs 1, and since they have the same output, they're equivalent, which means I did a good job. Make sense? Okay. No.
Because I was here yesterday for the explanation of how this works.
Oh, you missed the poop talk.
Oh, what?
I don't know what you're talking about. You what? What did you just say? You just loved it. You loved that story so much.
Not leave my mind. I'm
What
still
are
thinking
you talking about?
You're like,
it was just so funny. She also looked up our Spanish teacher today on Google. So it would be fine. Her address and phone number.
what?
Oh
I just want to remind you, I am recording, so. All right, example 8. Example 8. Okay. 9 to the negative 2x equals 1 over 81 to the 3 minus x. Whoa, fractions, Miss Rice, I'm scared. Ooh, 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 ooh. All right, so 9 and 1 over 81 show up in which column? The 3's, yes, they show up in the second column, which is the 3's column. So 9 is going to be rewritten as what? 3 to the 2. So 3 to the 2 to the negative 2x. And 1 over 81 is going to be rewritten as what? 3 to the negative 4. 3 to the negative 4 to the 3 minus x, okay? And so now we have exponents raised to exponents, so what do? Multiply. So first we have 3 to the negative 4x equals 3 to the... It was a test. It was a test and you guys caught it. Good job. Good job. Okay, so it's actually 3 to the negative 12 plus 4x. That's what you meant, isn't it?
I wrote it down as 9 to the negative 2. I don't know.
Here we go. Okay. So now that we have that, what should we do? Yeah, get rid of the bases. So we have negative 4x equals negative 12 plus 4x. And now what should we do? How do we do that? Add what? Add 4x to both sides. Now we can do add 4x to both sides, but then everything will be on one side. We want to do that. Okay, we can do that. So add the 4x, add the 4x. We get 0 equals negative 12 plus 8x, and we just move the 8 over, or move the 12 over. Okay. And then what do we do? Divide by 8. And so x equals 12 over 8, which is 3 over 2. So divide by 4, 3 over 2. Okay. And so if we wanted to check our answer, how could we check our answer? What about richly? Oh. So I'm going to do 3 over 2. I'm going to store that as x. And then 9 to the negative 2x is that funky decimal. And then 1 over 81 to the 3 minus x. is the same funky decimal. Have fun. Yeah. Yeah. No? No?
No, just calculate it as a fraction. And the
So
fraction
you
number.
don't have to check your answer every single time. It's just kind of nice to know that it's an option if you didn't feel great about your answer. If you got a weird answer and you wanted to know. All right, we're going to do one more problem that's probably like, when you see it, you're going to be like, oh, no, let's not do that one. Okay? And then we'll be ready for the activity. Okay. Last one. 625 to the negative 3x plus 3 times 625. Miss Rice, what kind of garbage is that? Equals 125 to the 2 minus x. What? What?
I know what the solution is.
Already?
Can you multiply them together and then do like 6.5 squared?
Okay.
625 to the negative 3x plus 4.
Yeah, there's a few different ways we could do it. So let's the 625s are freaking me out because they're real big. So maybe let's look at our sheet first. What column are we in? We're in the 5s. Okay, so let's rewrite this. So the 625s are actually 5 to the 4. Okay. So I've got 5 to the 4 and 5 to the 4. Okay. And then what's the 125? 5 to the 3. Okay. All right, so the exponent raised to an exponent, we do what with again? Multiply. Okay, so we got 5 to the negative 12x plus 12. And then 5 to the okay, perfect. And then we cannot just be like, ooh, cancel a 5, cancel a 5. And we can't just be like, ooh, cancel 5, cancel 5, cancel 5, because that's 3 of them. You see the issue? Okay. So what do you do? You add the exponents. So let's go back for those of us who can't see it. Let's go back and say we had x to the 3rd times x to the 5th. If you had x to the 3rd times x to the 5th, what do you actually have? X to the 8th. So this is the same thing as that, it's just a more complicated version. You guys see it? It's a more complicated version. So when you look at that, you say, oh, if I'm multiplying two exponential terms like this, if the base is the same, I can add the exponents together. Does that make sense? Okay, so 5 to the negative 12, or negative 12x plus 12 times 5 to the 4th would actually be 5 to the negative 12x plus 16. Marvelous. Equals 5 to the 6 minus 3x. Okay, now what can we do? Now the bases can go. Now the 5s are done. Okay. And then what if that hadn't been a multiplication problem? What if it had been a division problem instead? What would you do with the exponents then? Subtract. Does that make sense? If it had been 625 on top and 625 on bottom, you could subtract the exponents instead of adding them, right? So we know that this rule says, oh, 3 plus 5 is 8, but if we had had x to the 5th over x to the 3rd, then what would the answer have been? X to the 2nd, x squared. Because in this situation, you subtract. Okay, so it's possible when you guys do the activity today, they might have some problems where you have to add your exponents. They might have some problems where you have to subtract your exponents. Okay, so anytime you get confused by the way that it's written, think of it in terms of this. Go back to a simple example where it's easier for your brain to remember how to do it, and then apply that to the more complicated one. Okay. All right, so we have negative 12x plus 16 equals 6 minus 3x. And what should we do? Okay. And then what should we do? Okay. Okay. And so x equals 10 ninths. And if we want to check it, we can just plug it into our calculator and make sure the left side of the equation and the right side of the equation have the same output. Marvelous. Okay, so you guys know how the activity around the room works. You can work by yourself, in a pair, in a triple. You don't have to work in your group. You can work with whoever you want. Just make sure that your name is written on the notebook paper. There are 18 problems. I'm not sure if we want to do all of them or not. I will let you know. There is a little bit that we're going to do at the end of class and a worksheet with it. The part at the end of class that we're going to learn how to do is not a difficult thing. And if you have to take the worksheet home to finish it, it will not make you cry. You will not get frustrated if you have to do it at home, and it will be quick. Okay, so we will probably do this until there's maybe 15 minutes left in class, maybe 20 minutes left in class, and we'll see how far we got. So you have about 55 minutes, 55 minutes, and we'll see how far we get on the activity. All right, go ahead and get started. And if you were, I'd put a title on this. The title would be Converting Between Exponential and Log Form. Converting between exponential and log form, aka inverses. So the first direction we're going to go is we're going to start with the exponential form and we're going to convert into log form. We're going to start with the exponential form, we're going to convert into the log form. So first example, we have 8 to the negative second power is 1 over 64th. That's just true, right? 8 to the negative second is 1 over 64. If you were to plug that in a calculator, that would just be true, okay? So if you wanted to convert this into an equivalent equation that was written as a log instead of written as an exponent, you would just have to undo the base. And we can do that because exponential form and log form are opposites of each other. So you just have to think, what is the opposite of a base of 8? It is a log with a base of 8. So I'm going to get rid of the base of 8 by doing a log base 8 on the left side. And if I do a log with a base of 8 on the left side, I have to do the same thing on the right side of the equation because that's how you keep equations balanced. So I'm going to do a log with a base of 8 on the right side. Okay, so on the left side, whenever you do the inverse of something, it always cancels that thing out, right? I'll show you in a second. So if we had like a +2 and a -2, that cancels them out, right? Or if we have a multiply by 2 and a divide by 2, that cancels them out. So if we have a base of 8 and a log base of 8, those two things are going to cancel each other out. So I'm going to say, okay, cross this out and cross this out. Those two things canceled. So that leaves me with -2 equals log base 8 of 1 over 64. And so I just converted it from the exponential form into the log form. It's an equivalent equation. It's the same thing. It's just written in a different form. So it's like I converted it from Italian into Spanish. It's just the mathematical version of doing that. Yeah. Yes. We're going to do a few of these, and I have a worksheet for you. Yes. They're not bad. I promise. They're not bad. Okay. So let's try another one. Here's the next one. We have 225. 225 equals 15 to the second power. So this time we have 15 to the second power. That is the part that is in exponential form. So what is the base? 15. So how am I going to get rid of that and turn it into a log? Log base 15. So I'm going to log base 15 each side. Log base 15 the left side, log base 15 the right side. So the log base 15 and the base of 15 are the things that are inverses. Those are the opposites, and that's what cancels out. Does that make sense? The base of 15 and the log base 15, those are the things that cancel. So log base 15, 15, that's gone. So I get 2 equals log base 15 of 225. Done. That's it. That's all you have to do. Okay, next example. So here we're going to have 2 to the third equals 8. So if you look at that problem, what is the base? 2. So what log are we going to use? Log base 2. So I'm going to log base 2 each side. Log base 2, log base 2, and then which part cancels? The log 2 and the 2. Log base 2 and the base of 2, and so I get 3 equals what? Log base 2 of 8. Okay, so now let's do the opposite version, which is going to feel very similar if we start with a log and go to exponential form. Okay, so with this one, I'm going to say my first example is log base 12 of 144 equals 2. So we're going to do the same thing. We're always, whenever we do this, we're always looking at the base. So what is the base that you can see in this problem? 12. So if I want to get rid of a log base 12, I have to turn this into an exponential problem with a base of 12. Okay? So I'm going to make it an exponential problem with a base of 12 and a base of 12. Base of 12, base of 12. Okay? So the base of 12 and the log base 12, those cancel out because we just saw in all those 3 problems we just did, those were the things that canceled out every time, right? Base of 12, the log with the base. Okay, so those cancel out, and I just have the plain number 144. 144 equals 12 to the second power. Agree or disagree? Agree. 12 to the second power. Make sense? Okay, let's try another one. We have -2 equals log base 11 of 1 over 121. So what base should we use? 11, okay? So we're going to put plus of 11, a base of 11. And then what happens? Yeah, the log base 11 and the 11 cancel. Okay, so we're going to say that 1 over 121 is 11 to the -2 power. Does that make sense? 11 to the -2 would be 1 over 121? Yeah, that's valid. Okay. Okay, and then last problem, we're going to say log base 16 of 4 equals 1/2. Log base 16 of 4 equals 1/2. So what should we do? Base 16, base 16, okay? And so what cancels? The 16, the base 16 and the log base 16. And we get 4 equals 16 to the 1/2. We have to think back to math 2. Does that make sense? 4 equals 16 to the 1/2. What's a 1/2 exponent? It's not a negative. What's a 1/2 exponent?
That's the root.
It's a radical. So 16 to the 1/2 is the same thing as the square root of 16. Is 4 the square root of 16? Yes. So this is correct. This makes sense. Okay. So we're good. How are your brains feeling? Great. Okay. So it looks funky, right? This looks really weird, but we can just see the base of the log, the base of the exponent, they cancel. Do we see that? How they're opposites of each other? So it's an inverse operation that is really uncomfortable. We've never seen it before, but can we see how they would cancel each other out? Okay. So I'm going to pass. You guys do not understand. When I got the kitten, he was literally 2 pounds. Oh,